Now friends, let's take our next question, that is question number 13. The question you see here belongs to section of electromagnetism from chapter electrostatics. The parallel combination of two air-filled parallel plate capacitors of capacitance C and NC is connected to a battery of voltage V. When the capacitors are fully charged, the battery is removed and after that a dielectric material of dielectric constant K is placed between the two plates of first parallel plate capacitor. The new potential difference of the combined system is, so we have to find the value of the new potential. Let's start the solution. So currently there are two plates like this in parallel combination. This is C, this is NC, and they are connected to cell of V, right? So what is the net capacitance here? So when you write the net capacitance, that would be simply N plus 1 into C, right? Then when you talk about the charge, so Q would be equal to C net into V. So this Q can be written as N plus 1 into C into V. So we have the net charge on the system, right? When you remove the connection from here, in that case the charge on this system will become constant. So when the batteries are removed, this charge will remain constant, it will not change. Now with the same combination we did what? We added a dielectric in between the plates here. So now this becomes Kc and this is Nc. Now what is the new C net? That would be equal to K plus N into C, as it is a parallel combination, and the new potential difference V dash can be written by charge by C net dash. But the charge on this combination is constant as the connection from the battery has been removed. So Q will be this as we have found here. So V dash would be equal to N plus 1 CV divided by, what is the C net? K plus N into C. When you solve this, you will get V dash as N plus 1 V divided by K plus N. Let's see which is the best suited option among the following four options. So when you see here, option number 1 would be the right answer to this question, right? Now let's move on to our next question. In this question, you see this belongs to section of modern physics from the chapter Communication System. As per the question, the physical sizes of the transmitter and receiver antenna in a communication system depends on. So size of antenna is dependent on the wavelength of the carrier wave, right? And the wavelength is inversely proportional to frequency. So among the four given options, option number 2, that is the size will be inversely proportional to carrier wave's frequency. Answer to this question would be option number 2. I hope you have understood this one. Now let's move on to our next question. Now the question you see belongs to section of mechanics from the chapter work power energy. Here a wedge of mass capital M, which is equals to 4 times small m, lies on frictionless plane. A particle of mass small m approaches the wedge with speed v. There is no friction between the particle and the plane or between the particle and the wedge. The maximum height climbed by the particle on the wedge is given by. So in order to solve this question, you need diagram. So I have already made one for you. Here, this is the mass, that is small m. This is 4m wedge. This is moving with velocity v, right? Now when this will go, it will after some time will reach up. After a particular height, they both will attain the same velocity in this direction, and after that the ball will not rise further. So let's take this as the final condition where ball has risen by height h and both are moving with same velocity v1 in this direction. So here what was the initial momentum pi, that is equals to mv. What is the final momentum? That would be equal to mv1 plus 4mv1, that is equals to 5mv1. Then what is the energy here? That is total energy of the system, that is equals to half mv square. What is the total energy here? That is final condition. So you will get mgh, that is the potential energy of this mass, that is small m, then kinetic energy of this mass, that is half m v1 square, then for this it would be half into 4m into v1 square, right? Now when you solve this one, there is no external force applied, so initial momentum should be equal to final momentum, right? So this is m into v should be equal to 5m v1. Solving this, you will get v1 is equals to v by 5, right? Now this is one important observation. Then total energy initial should be equal to total energy final, right? When you put down the values here, you will get half m v square equals to mgh plus half m v1 square plus half into 4m v1 square. Now when you solve this one, you will get half m v square equals to mgh plus, this can be written as 5 by 2, that is 4m plus m, that is 5, m into, in spite of v1 I can write v by 5 whole square, right? Now when you put down the values, you will get h is equals to 2v square by 5g. Let's see which is the best suited option here. So among the 4 options given to us, option number 2 would be the right answer to this question. I hope you have understood the question very well. Now let's move on to our next question.